In this problem, we'll do page 14, number 2. 5 people enter a racquetball tournament in which each person must play every other person exactly once. Determine the total number of games that will be played. Well, we're going to first of all create a visual model of this, and I've listed the 5 people represented by those 5 circles. And we'll call them player 1, player 2, player 3, player 4, and player 5. And the way we'll represent the games that are being played is by a line segment connecting 2 of the points. So for example, the line segment, the blue line segment connecting player 1 and player 2 represents a game played by players 1 and 2. We have another segment connecting players 1 and 3, another connecting players 1 and 4, and finally one connecting players 1 and 5. Now we can represent these 4 games using notation P1, P2, P1 and P3, P1 and P4, P1 and P5, representing the 4 games that player 1 is going to play. Okay, so let's go on to player 2. Well, player 2 has already played one game. He's played the game with player 1. So I'm not going to draw another line there. I'll just put a check on that, a red check this time, to show that player 1 and player 2 have already played. Then I have a line connecting player 2 and player 3, a line connecting player 2 and player 4, a line connecting player 2 and player 5. So now player 2 has also played 4 games, and that would be with player 1, player 3, player 4, and player 5. You can see them all either as red lines or as that check mark there. And I add the 3 games notation-wise over on the right side. Alright, we'll go on to player number 3 now. Well, player 3 has already played players 1 and 2, so I put green check marks on those segments indicating the games player 3 has already played. And I have a segment connecting player 3 and player 4, a segment connecting player 3 and player 5. And so now player 3 has played 4 games. And that's with player 2, player 1, player 4, and player 5. 2 are check marks and 2 are new line segments. And again, I add using notation the additional games played by player 3 that weren't already recorded on the right hand side. And now we go on to player 4. Well, player 4 has already played player 1, and I use a purple check mark to highlight that game. He's already played player 2 and player 3 as well. So there are 3 check marks for games already played, already recorded, that have been played with player 4. The only other game that hasn't been played is with player 5. And so I record a new line segment connecting player 4 and player 5, and I record that game on the right as well. So now you can see that we have 10 games played by all the players, and that has solved the problem. It's interesting to note that when we group them in this way, we also have 4 plus 3 plus 2 plus 1, or the sum of the first 4 positive integers. And another way of looking at this is that you had 5 players. Each player played 4 games, so that would be 5 times 4, which is 20. However, when we say each player has played 4 games, we're double counting every game. So we had to divide that by 2, and we got 10. Now, I use the formula for triangular numbers, which you can see we have, since we have the sum of the first 4 positive integers. However, you have to be a little bit careful in this case because although we're playing with 5 people, we're not going to do n equals 5, which would be 5 times 6 divided by 2, and that would give us 30. That would give us 15. So we're actually using n equals 4 here, and that would be n, 4 times n plus 1, which is 5, divided by 2, and that would give us the 10. So you have to be careful using the formula for the triangular numbers to use it properly here. But there are a number of different ways we did this.